Hello everybody and welcome back to Business Statistics Online at Frederick Community College. In this video, I will talk to you about goodness of fit problems and how to use Excel to solve these problems. So if you would like to follow me along, you will need to have access to three items. First, you will need the Excel file that I uploaded for you guys on Blackboard, and it's the file that is titled chi-square test for chapter 12. Okay, and we're going to be using the first tab that says goodness of fit. Then you can also use the worksheet uploaded for this chapter as well. So the worksheet has two problems. One is the goodness of fit problem, and that's what we're going to do in this video. And then the second page has a problem for test for independence. And there will be a separate video associated with this problem. Okay, and then we will need access to our course on My Math Lab because we're going to need to use one of the tables. So those are the three items that you will need to have access to. Okay, let's take a look at the problem that we're going to solve and how to approach general problems that deal with goodness of fit. Let's say we have a report from Gartner Incorporated that says these are the percentages, the market shares for smartphones. Okay, and they give us the percentage for each type of smartphone. So let's say 56% represents the share for Android. Okay, what is the goal of this problem? The goal of this problem is to collect a sample, and we have a sample right here, and test if these numbers agree with the report that's given by the company. Okay, so in general, we want to see if the observed frequencies follow a known distribution. And in this case, it's the report by this company right here. So let's write out our null and alternative hypothesis. And for these type of problems, you would just write it in plain English. You will have a sentence. Okay, something like observed frequencies follow or agree, let's say agree with the report by Gartner Incorporated. Okay. All right, this just says yes, our numbers in the sample do follow the distribution given by this company. And then the alternative hypothesis will always say no, some of these categories have different percentages, or in general, the observed frequencies do not agree with the report by Gartner Incorporated. Okay, and that's always going to be the case. So the null hypothesis will always say yes, our frequencies do follow some distribution, and then the alternative will say no, some of the numbers are too different. Okay, so what we're going to do next is going to use our Excel file to come up with chi-square test statistic. Okay, just like we've done with hypothesis testing, we used z-test statistic or t-test statistic. In this case, we'll be using a different distribution function, and it's called chi-square distribution. Okay, so let's go to our Excel file and see that over here, I've already typed in all my numbers. Okay, and the sum is 120, which I will be using when computing expected frequency. Okay, let's see what expected frequencies are. Well, I need to use this information right here to figure out what my expected frequencies are. So 56% of all smartphones should be Android, right? So I'm going to use 120 times 0.56. Okay, and let's just take a look at this category. So for Android, the expected frequency was 67.2, and if it's a decimal, it's completely fine, but we got 62. Are they different? Yes. Are they different enough? Well, that's what we're going to find out at the end of this problem. Okay, and now we just need to do this computation for every category. So the next one is 23, so it's 120 times 0.23. then 9, 7, and 5. So 9% would be 120 times 0.09. 7.07. And 5, that would be times 0.05. And over here, this is my way to check that I'm doing my computations correctly. So the totals are the same, right? Okay, and now I'm just going to observe these numbers. So 9 is different from 6, 12 is different from 8.4, and all of these categories have different values for observed and expected frequencies. But the question is, are they different enough? Okay, so chi-square statistic, test statistic, how is that computed? We're going to do the following computation over here. I'm going to say observed value minus expected value squared divide by the expected value. Okay? And I need to do all of this for every one of my categories. So I'm just going to drag it down. Okay, so these are the values that we need to add up over here, and you can see that I already have the sum set up. It's actually going all the way to this cell, but that's fine. So this is my test statistic. That's going to be my test statistic. So we don't really know what to do with that quite yet. Okay, now let's see. Let's go back to our problem. So over here, you would plug in your expected value. So 67.2, and the next one was 27.6. Nokia was 10.8, 8.4, and 6. Okay, these are my expected values. Let me highlight them. Okay, are they different? Or our observed values, are they different? Yes. Are they different enough? Well, we don't know. So chi-square test statistics, this is the value we compute. Okay, that is the sum of observed minus expected squared divided by the expected. So 3.823. 823. Okay. The chi-square critical value, this is a table value. So now we're going to go to, well, actually I computed for you here, but let me show you how to do it on the table. Let's go to our course page, go to course tools. Nope, just kidding. Chapter content. And we're going to scroll to appendix. And over here, you're going to see all these tables. We're going to take a look at chi-square distribution. Okay, it will take some time for it to load, but I actually want you to see the picture of this distribution. There you go. Okay, you have this picture right here that suggests that all of our tests will be right tail, and the answer is yes. Okay, so chi-square of alpha, that is the critical value that splits your distribution into critical region right here and non-critical to the left. Okay, so how would we find the critical value from the table? Let's go back to our problem. This will depend on the alpha level and number of categories. So number of categories in our case is 1, 2, 3, 4, 5. Okay, that is 5 categories, and alpha is 0.05. So there is a value that's associated with chi-square distribution. The value is degrees of freedom, and all that is number of categories minus 1. So if I have 6, well, in our case it's 5 categories, right? So 5 categories, then the degree of freedom will be 5 minus 1, that's 4. Okay, so let me go back to my table and find the critical value and see if it matches our computed value in Excel. So I'm looking over here, 4 degrees of freedom, and then over here I'm looking for my alpha level, which was 0.05. So I need to look at the row corresponding to 4 degrees of freedom, and critical value 9.5. 488. Okay, let's change this over here to 0.05, and there it is. There is your critical value, 9.48, right? So Excel actually computes it with a little bit more accuracy, but over here on the table, again, let's see which one. This is this piece right here. It's 4 degrees of freedom. Alpha is 0.05, 9.488. This would be the value split in the distribution to critical region to the right, non-critical region to the left, which means what for our problem? Let's go see. What is our critical, our test statistic? 3.823, right? Let me write my critical value over here. 488. 488. Okay, what does that mean? 3.823 does not fall into the critical region. We failed to reject the null hypothesis. Okay, and then our last line would say there is insufficient, nope, I can't type today, evidence to claim that what? To claim this. You can literally just retype the whole thing. There is insufficient evidence to claim that observed frequencies do not agree with the report, which means what? Our observed frequencies are not different enough from the expected. Are they different? Yes. Is the difference significant? No. Okay, so you might notice that with chi-squared test, the p-value method is actually usable in this case, right? Let me actually see. Do I compute the p-value for you? That is not right. I will have to fix that right here. Actually, no, this is correct. The p-value is still done. Okay, so I'll compute the p-value for you as well. 0.43. What does that represent? That actually represents the area that is cut by the chi-square statistic. Okay, so this would be 0.05, and then if you put your chi-square statistic on this side, then the area would be 0.43, which is really, really big. Okay, that's a lot bigger than alpha level, which is 0.05. So either way, we fail to reject the null hypothesis, which means the sample does agree with the distribution that's given by the company. Okay, so what's the general setup for this type of problem? Okay, first, compute your expected frequencies. Sometimes you will be given percentages. Other times it will say something like, well, the distribution is uniform, which means all of the categories have the same percentage. Okay, write out your hypothesis in the context of the problem. Find the chi-square on test statistic or the p-value. Find the critical value from the table. Compare these two or the p-values, whichever method you would like. It doesn't matter. You should still get the same conclusion. And then write the conclusion in the context of the problem. Okay? So I hope this was helpful. Thank you for watching, and check the next video, which will be dealing with tests for independence. Still doing chi-square distribution, but a slightly different setup and a different tab for computations for this type of problem. Okay? All right. Thank you for watching.